Hello students, welcome to Laboratory B2 Parallel Circuits. Today we're going to be dealing with some unknown values. We're going to talk briefly about that. If you look at the sheet that's on page 42, you'll be able to take a look and see what we're talking about here. Is that as I'm looking at this information trying to solve for the unknown values, I have to have at least two unknowns in order to calculate the known. If I'm looking at resistor 1, there's no value on this chart for resistor 1. Resistor 2 only have one value. Resistor 3, there are two values here. I have current and power. Resistor 4 is only one, and the total is I only have the total resistance in this case. So we're going to take what we know to figure out what we don't know. So we're going to start with resistor 3. And in this case, we're going to take a look here at resistor 3. And with resistor 3, we're going to have to use the power wheel. In the power wheel, you should have received one of these in one of your classes, but you have power wheel is that all the formulas, here's two of our formulas, calculate for voltage and current in ohms and watts. So we want to solve for the voltage on R3, so we know what the power is and what the current is, so we're going to say that volts is equal to watts over amps. So when we're doing this, we're going to use the power wheel to find the unknown values for R3, the current and the power of known. So now we can do this calculation, which I've done here on this page. As you can see here is a voltage of 3 as I take the two values that are in my Verpi chart to do those calculations. And remember, this is a parallel circuit, so voltage will be constant. So once I find the voltage for 3, as I know the voltage in all those cases, and I can simply fill that voltage right here and then finish the rest of the Verpi chart. So that's where you're going to start on this lab, doing the calculations. Now once you've done the calculations and you know what those values are supposed to be, you're going to build a circuit. And you're going to draw these on the next page, which is 43. So you're going to fill out this chart, the top and bottom. The left side is just going to be the circuit, the schematic. And the right side is straight line extraction. This is how I would show my students how to do this information here. So this is with 4 resistors that are in parallel. This is how I would do just a straight line extraction. And I probably would write the values of the actual resistors in there once I figured out from my first chart. Remember again that with a parallel only circuit is that the voltage will be the same on each one of those resistors. Is that this is known as a current divider because it divides the current up and the voltage is constant. And we're dealing with another law that we call Kirchhoff's current law. And Kirchhoff's current law says that the sum of the branch currents equal to total current. What that means mathematically is we just take each of the branches, the current that goes through R1 and then R2 and R3 and R4. We take those 4 currents in this case and add them up to get my total current. You're going to find your resistor. Once you figure out what the circuit should be, you're going to fill out this top chart for circuit 1, and then you're going to fill out the bottom chart. They're all actual measurements, no calculations on that part of the table. And just as a reminder, you can build these circuits in 2 different configurations. This first circuit is I can use the bus line at the very top of the line here, and I can just hook all those up together to this red bus line here. And then what I've done at the bottom part of the circuit is I've just used jumper wires, and I've brought that down here to this bottom bus line, and this red and black lead is what will connect to the power supply. So take a look at that. If you have any questions, make sure you talk to your instructors and get him to take a look at your circuit once you do that. Another way you can build this circuit is if you want to build it with the least amount of jumper wires, you can do it this way. You put your resistors, all the tops are connected to this red wire, all the bottoms are connected to this black wire. Power supplies there. So there's another way to do this. You're somewhat limited on how many resistors you can put in here when you're not using a bus line. So take a look at that, talk to your instructors, and make sure you can fill out that information that's requested on the lab. And again, we'll see you in the lab. Take care.